Hi and welcome to this video about Windows services. In this video we'll take a look at the basics of Windows services, and in the next video we'll see how to write a service. So what is a service anyway? The term service in general is highly overloaded in the software systems these days. What I'm talking about here are Windows services, the classic definition of a Windows service, which is a process that provides some kind of functionality without being tied up to any kind of logged-in user. In fact, a typical reason to run a service is not to be tied to a user, and so a service can run without any user being logged in. You can think of some kind of server that might be in some server room and maybe even in the cloud that runs some service that provides some kind of, service based on clients connecting to it. Here are some classical examples, such as a web server. You have a web server. It's built around a service that listens to TCP requests under some set of ports like 80, 443, and so on. Another example is a database server that listens to database requests coming in through some mechanism like a TCP IP port or named pipe or any other mechanism that makes sense and usually is configurable with that particular product. And so one of the differences between a normal process and a service is that a service has to communicate with this entity called the Service Control Manager, or the SCM. And this is the entity that actually controls services. So it allows us to start a service, stop a service, pause a service, resume a service, interrogate a service in various ways, depending of course on what the service actually implements. I will say in parentheses that Windows 10 and later support the idea of a service that is tied to a specific user being logged in, and that is useful in certain cases, but this is not the most common way to work with a service. So let's see some information about services with various tools. So first, Windows provides the services applet you can find by looking it up just using the start button. And this shows a graphical interface showing information about all the services that are installed on the system. And so every service has some kind of name, which is really just it's a display name. It's actually a nicer name for that service. It has a shorter name, which corresponds to a key in the registry, which we'll see very soon. There's a description that might exist for that kind of service. And since most of the services are built-in Windows services, Microsoft does provide nice descriptions for most of its services. And then we have the status here indicating whether that particular service is currently running or not. When you see running, it means there's some process hosting this service. If we don't see that running, it means that this service is currently not loaded. And we can right-click here and use the start option here to launch the service. And so this is only possible by default by admin users, because managing services is a privileged operation. It cannot be done by standard users. So I've now started this service. If I don't need it anymore, I can use the stop here to try to stop the service. And then we have something called a startup type. So startup type indicates when should the service start to begin with. And there are a few options here. One of them is called manual, as you can see here. Manual means that the service does not start automatically, but instead can be started manually by using the UI here or calling the Start Service API, which of course is what is happening when you use the UI here, or some other kinds of tools such as the SC tool, which we'll see very soon, or PowerShell. All of them at the end of the day will call the Start Service Windows API to start the service. Another option which is very common is called automatic. Automatic means that the service starts automatically when the system starts without requiring any particular login. This means that this is a service that is probably very important and it's a good idea for it to start automatically. There are some other options here. If I just double click here, we can see that we get some more properties about the service in question. In the startup type, we can see some more options. One of them is called disabled, which is probably the most boring one, indicating the service should not be starting in any kind of way. So the only way to go and change that is to change the startup type to something else and then start the service, maybe to manual, then start the service. This of course can only be done by administrators by default. There's another option here called automatic delayed start. And so the delayed start idea says that I want the service to start automatically, but maybe not immediately, because when the user logs in, if the user logs in real quickly when Windows starts up, then there's some kind of rush there to run all the services and also initialize the user session, the desktop and all that kind of stuff. So in order for the user to start as quickly as possible to be able to do their work, it's best that services hopefully would not interfere too much. So automatic services will start automatically as quickly as possible, but if you have delayed start, the services will be delayed by roughly 2 minutes, and also their initial thread will start with a low priority. The idea here is that the service is important to start when Windows starts, but maybe not critical to start immediately. If it's just being delayed by a couple of minutes, that wouldn't be any problem. There's another option for startup type, which is called trigger start. And this is something that is not available through the UI, but can only be done using tools or the API, of course. And the idea here is that the service shouldn't really start unless a certain trigger, certain event occurs. For example, if a service needs connection to the internet, then if the device is not connected to the internet, there's no point in starting the service. And when the internet connectivity comes in, if it is available, then the service will start. So this is the idea of trigger start. Unfortunately, the UI here is not too specific about that, just says there is some trigger start here, but doesn't specify and doesn't show us the actual trigger. Another thing we see here is the log on as, indicating under which user should the service run. And typically services run under one of 3 special Windows users, called this local system or simply system, which is the most powerful one and has administrative capabilities. Or if you don't need that kind of power, then the next one in line is network service, which allows has less privileges locally, but does allow authenticating outside the machine. It's not, it has some kind of identity which is based on the machine. And the least powerful is the local service account, which has no identity outside the machine. So you can only access network resources which allow anonymous access. If we double click again and see what's going on here, we can see the display name here. This is the actual service name, which is the key value in the registry, the key name in the registry, which we'll see very soon. We can do a start and stop and things like that and change the startup type if you have admin powers. In log on, we can see the actual user being used to run this particular service. It is possible to run a service under some other specific user, like a human user or some other account we create, but this is not a very typical thing to do. Usually we're going to be running under one of the 3 users that Windows provides. And then in the recovery tab, we see some more options. For example, what happens if the process, the service is running under shuts down prematurely, that is, crashes? What should the service control manager do? So the first failure in this little example says restart the service. If it fails again, if it crashes again, then restart it again. But if it crashes for a 3rd time, do nothing and reset the counter after 1 day in order to figure out what's the 1st time, 2nd time, and 3rd time, and later. So we have some nice configurability and control here being provided by the service control manager. And that's nice, because if you would have to do it yourself, probably you could, but it would force you to write code and test that and all that kind of stuff. You get a lot of this functionality built in as part of what the service control manager provides, which of course is nice. There's also dependency tab here indicating what are the dependencies of this service, which services are dependent on this service, and on which services this service depends on, if there are any. In this particular case, there are no dependencies, but other services might have some dependencies. So we can definitely try to find some of those. Maybe we'll find someone that has dependencies. They definitely exist. It's just a matter of locating one of those that have dependency, usually under maybe the RPCSS service, which is the one providing some networking support. So here's an example where we have this particular service that happened to open here like completely randomly, has a support, has a dependency on the RPC service, but no other service depends on this service. And if there are dependencies, then the service control manager will make sure that dependencies load up before the actual service and will force them to load if so desired, if that is actually needed. Okay, so that's one tool we can use to see services from a configuration perspective. Since we don't see all the options, you can use another tool, which is one of my tools called System Explorer, that has an option here under System called Services that shows more information about services in a tabular form. So we can do stuff like sort by various columns. So we mentioned the idea of a name, which is the registry key name, which we'll see, the display name. We've seen that there's also a description, which we can show here as well. That's the state, whether it's currently running or stopped. And there's some other information here, such as whether it is running in its own process or could be shared with another service in the same process. If it is running, you can see the actual process ID and the process name hosting that service. We'll get to that momentarily. That's the startup type, similar to what we've seen in the services applet. That's where the binary path actually is. That's the executable path. This information is available in the registry, which we'll see, and of course using APIs. That's the account name and something called error control, which I'll describe briefly very soon, and what the service supports in this case. So it might support stop, it might not support stop. This one, for example, supports pause as well and continue. Not all services support that. And we can right click here in the columns area or go to the columns button to add even more information, such as the full description, the privileges the service has. And one of the nice things about services, you can give them any privileges that you want that are needed for the service to properly work. You can see the list of triggers. For trigger start services, there's the dependencies and there's some other stuff here which I won't be covering right here. And so if we go ahead and look at that, we should be able to see more information. For example, here's the privileges that are assigned to this service, so essentially to the process running this service that are stored in the token for that service. So you can see exactly what each service has. Some services are really powerful, having privileges like the TCB privilege, which is a very, I would say it's a super privilege, one of the super privileges that allows a process to do basically anything. It can impersonate any user, for example. So essentially, if you have the TCB privilege, you can do practically anything. And you can see here the list of triggers for each service that has a trigger start service configuration. And feel free to sort by any column that you see here. So you can see the network endpoint is required here, some other things like a certain device arriving, that is some hardware device plugged into the system. You can also customize some properties of that hardware device and so on. So again, we have here some declarative aspects of services. We can still use right click to stop and start and do stuff about a service. We can see here very quickly which service is currently running and which is not. Now, going to other tools such as Process Explorer. With Process Explorer, we have these processes that have this color, which is the pinkish color. So all the pinkish color processes host services. If I double click any one of them, we'll see there's a tab called Services, which only appears for processes that are hosting services, one or more. In this particular example, we have a service hosted in its own executable as just the one, and that's the service name as a key in the registry, which again I'll show you very soon, and that's the display name of that service. So you can also do stop and start here based on the state of the service. So here's another one, another service hosted in its own executable, which is common for services coming from third-party vendors, that is not coming from Microsoft. But some Microsoft services actually are like that as well. However, the more common case, you can see here a few more services here that are hosted in their own executable, like this thing, DDV Data Collector. I think this is from Dell, as you can see here. This is a service provided by Dell because Dell runs some services on my machine, being a Dell machine. Now, if we go all the way to the S here, we can see there's SVC host. So there are these multitude of SVC hosts hanging around, and this is known as the generic host for Windows services that is provided by Windows to host services. And the idea here is that the service itself is implemented as a DLL. Here's an example for some service here that is implemented as a DLL. And this generic executable hosts and loads that DLL and exposes that as a service. And you might be wondering, why is it built around this architecture? Why not have every service being their own executable, implemented in their own executable? And the reason has to do with the fact that Windows has built-in many services, and if you go ahead here and maybe sort by status, you'll see that many services are running on a typical Windows system. We're talking about dozens of services. And so the idea was that since if every service would run in its own process, that would be fairly expensive. And so Microsoft came up with this idea, started with the first version of Windows NT, to host multiple services in a single process, and in this way conserve resources. If you have less processes, you have less resources being consumed. Essentially, you're consuming less memory. So if you have multiple services, each one would have to be implemented as a DLL to be able to be hosted in the same process. So that was the idea, and up until Windows 10 version 17.03, that was the normal way of working. And so the number of SVC host instances you would find would be much smaller than you see on a typical system today. But this idea, which is used to conserve resources, has some downsides. And basically there are two downsides. The first one is the dependencies between services. So if one service crashes, for instance, causes an unhandled exception, the entire process shuts down, meaning all the services that are in that process will crash, and there's nothing they can do about it, which means that we have this robustness problem perhaps, because one service that has nothing to do with another service in fact crashes the entire set of services in that process. The other potential issue is that all those services running in that same process will have to run under the same user account. So they have to run under the same account. They can't run under different accounts. So it must be properly segregated so that everything works as expected. So Microsoft decided to change this idea in Windows 10 version 17.03. That's the third Windows 10 version. And if the system has 3.5 gigabytes of RAM or more, then the things change. So instead of hosting multiple services in the same process, we have now the case where most processes are hosting a single service to make this more robust. So if this service, for example, crashes or causes some kind of unhandled exception, it can only bring down its own process and has no effect on other services. So you might be thinking 3.5 gigabytes of RAM, I mean, that's like nothing. What system doesn't have 3.5 gigabytes of RAM? So for today's system, that is technically correct, but remember there are also other kinds of devices Windows 10 supports, various IoT devices like HoloLens, and there was Windows Phone at the time, and Windows Phone at the time had only, in typical systems, 2 or 3 gigabytes of RAM. So in those cases, the original scheme would have been used where you have less SVC host instances, each one would host multiple services. But on today's system, this is the default way of working. It is possible by changing some registry value to revert to the classic way things were working, but it's not what you find on a default system. So each service will be hosted in its own process almost. You can see here two examples, an example of a process hosting more than one service. There's another one of those, something like this. You can see here we have a bunch of services, 5 services hosted in the same process. These are very important services, at least some of them, such as DCOM launch service. And so there's some reasons internally that make it that they're all these 5 services hosted in the same process, but this is not the normal case. So this is kind of a unique thing. For all other services, you'll find that they're hosted in their own process, which provides extra robustness at the expense of perhaps wasting more memory. But it's not considered too bad because you have lots of RAM, you have lots of memory that should be good enough. But as I mentioned, it is possible to revert to the old scheme if you so desire. Next, let's take a look at the registry, where things are actually being stored in terms of the database the Service Control Manager is actually managing. By the way, the Service Control Manager itself is implemented in the process called services. So if you look at services.exe, this is the scum. This is a service control manager. It's hosted right here. You might notice it's also a protected process, so very difficult to kill. You can't really kill it from user mode under Windows 8.1 and later. So services obviously is the one that's managing, services, and the way it does that is by having a named pipe being used to communicate between the services and the SCUM. So in the registry, the information is stored here about services under HK local machine, system, current control set, services. And the thing is that within services, you actually have two different things being registered here. One of them are really Windows services, but the other thing are kernel drivers. So kernel drivers and Windows services are stored from a configuration perspective under the same subkey here called services. And you might be asking, why is this the case? I mean, kernel drivers and Windows services are really very different kind of entities. Windows services run in user mode. Kernel drivers run in kernel mode. Their purpose is very different. They work in a different way. You use different APIs. It's all kind of different, but still they're hosted under the same registry key. And the reason, of course, is on the one hand historical, on the other hand it makes some sense, because sometimes kernel drivers are referred to as driver services, because really a driver provides some kind of service to the system, but of course it provides that kind of service from kernel mode. Also, the service control manager is also able to start kernel drivers. Once it's up, it can start kernel drivers as well, not just user mode services. So there are some commonality there, but still from a practical perspective, the way you write services and the way you write kernel drivers, that's completely different and really has no relation. But still, it is what it is. It is under the same key, and maybe if Windows would have been designed today, things would be different, but it is what we have. And so when we take a particular item here, a particular node here in the registry, how do we know if this node represents a service or a driver? And the way to see that is using this value called type. If the type is a small value like 1 or 2, this is a kernel driver. If the type is 16 or higher, that is 10 hex or higher, this is a service. So you can think of the services applet as like scanning the registry and only showing those entries that indicate the type is 10 hex or higher. So in this example, ACPI is a kernel driver. It's also pretty obvious because the image path here is pointing to a sys file, which is the typical extension used for kernel drivers. This is a driver as well, type is 1, and this is a driver as well, and this as well. And finally, we'll probably find some services here because obviously there are many services in Windows. We'll find some. So here's an example of a service called AJ Router. This is the name, that is the short name. And then you can see here that there's the image path, which indeed is svc host.exe. It has some parameters here, and this is the way that there's a different key in the registry that talks about how multiple services should be hosted in separate processes if we would work with the original scheme. So this one is a service, and you can see here the object name, which is the user that should be used to run this service. In this case, it will be local service. We can also see that there's a start value here. So the start value in general has 5 possible values and indicates when should the service or driver start. Let me briefly cover these values. The lowest one is 0, which is called the service boot start. This is only valid for kernel drivers. This is used for boot drivers that have to load very early when just the kernel just starts booting up. So this is not available for services, but of course it is available for drivers. So the ACPI driver, for instance, has a start of 0 because it has to start really early. It's the one managing the plug and play tree, stuff like that. So it has to be available very early in the lifetime of Windows. Going back to other values, we have the next one, which is 1. Value number 1 is called service kernel start and system start. This is also can only be used for kernel drivers. This is when the kernel is already initialized and drivers can run at that point, load at that point. At that point, there is still no user mode around. So again, the value of 1 is not available for services. The next value, which is number 2, that's the first one that is available for services. And in fact, this is exactly the meaning of automatic. When you see something here called automatic, it just means that the value of start is 2. That's what we have in that case. For AG router, the value is actually 3. 3 is the next one in line, which is called service demand start, essentially saying this is a manual start. So everything you see here is with manual, meaning the start value is 3, which means that the service or driver doesn't start automatically, but it will start if requested to explicitly, by using some start service API or another tool that would call the start service API. The last value is 4, which simply is called service disabled, meaning that that service or driver cannot start unless you change that value to something else, which of course can only be done by administrators in general. So sometimes you see the value of disabled. So basically, if you look at the list here, you'll find some kernel drivers, you'll find some services, and the way to make the distinction is based on the type. Now, what is the meaning of type exactly? So we have 10 hex and 20 hex and some other values, basically indicating whether the service can run in its own process or it can run with shared with other services in some process. So there's some distinction with these values, but not really that important. By the way, Task Manager, if you look at Task Manager here, we can see that there's in fact a Services tab here, which is kind of similar to what we've seen in Process Explorer perhaps. We can see here the name of the service, that's the short name, the one that you would find in the registry, that's the registry key name. There's the description here, and you can see the PID. So the process ID, if it's not 0, if it's not empty here, it means this is a running service. And of course, the status also shows running. You can see the group, and that group really is the one that's passed in as a parameter to the command line of SVC host to host that service in a certain group if we have the old scheme of working. You can also right click here and go to details to find the specific SVC host where that particular service is hosted. So that's kind of nice. In fact, Task Manager provides this functionality very similar to what we see perhaps in Process Explorer. So this is what we see here in the registry, just from a configuration perspective. Lastly, we have the ability to work with services using tools, like command line tools. So we can use PowerShell or the SC tool. The SC is the classic tool. So for example, the SC tool can do anything that really is supported for services and drivers in this respect from a management perspective. For example, it can query the state of some service. So if I look at some service name like ALG here, I can do something like SC query ALG. It's going to tell me that this ALG service is actually stopped, which of course we can see indeed this is the case. I can use that to start the service by using start with the name of a service or a driver. Notice it has started successfully. We can see the process ID here being created, shown here, and now the service in the running state and does whatever. We can stop it. And again, of course, we can query it right now and see that it is currently running. It also shows here that it is stoppable, but not pausable. So it provides information as to what is supported by the service from a control perspective, and we can stop it. So you can do a stop ALG to stop the service. Once we do that, notice that it is being stopped. And this is done by communication happening from the service control manager to the actual service itself. Like I said, through a named pipe, and we'll talk about that and what APIs are involved there the next time when we see how to implement a service and try to kind of bring all these things together. And so these are just some of the commands that SC supports, and you can use PowerShell as well if you prefer, which is perhaps easier to use as it's more powerful in general. So there are commandlets like start service or get service to get a list of all the services. And of course, you can do with PowerShell easier filtering, other that kind of work. I'll leave that to you to try it out yourself. Just make sure you're running with admin privileges to do any kind of work with services, because that's the way services are built. They require high privilege to access their functionality. So this is for today's video. In the next video, we'll see how to write a service using C or C++, and then talk about some other aspects which are more internal in nature when creating services.